Hello everyone. What we'd like to do in this video is discover the law of cosines or give a proof to the law of cosines. I know a lot of students get kind of nervous maybe around the word proof. Really, what we're just going to be doing here is just looking at a non-right triangle, playing around with it a little bit, and see if we can get the law of cosines to pop out. So don't let the word proof kind of scare you away from this video. We're really just going to be doing some exploring. This is very accessible. Okay, so let's discover the law of cosines. Okay, so what we're going to do is mainly we're just going to be playing around with our right triangle stuff on a non-right triangle. So you'll see what I mean here. So let's draw a triangle, general triangle. So this is angle A. This is angle B. We'll call this here angle C. This will be side length A. This will be side length B, and this will be side length C. Okay? So the thing is most of the tools that we have when we're working with trig functions, they only work with right triangles. And the Pythagorean theorem only works with right triangles too. If you haven't seen my video for the proof of the Pythagorean theorem or an argument about why it's true, make sure to check out that video. So I don't know how to work with this non-right triangle. So what are we going to do? I know how to work with right triangles, so we're going to make a right triangle. So we kind of did a similar idea when we were doing the law of sines. But what if I force a right triangle here? And now I have something I know how to work with. I know how to work with right triangles. So now we have this nice 90-degree angle here, and we've created two. I'll do this one here. Do this one here in blue. We have two right triangles. We have this one. I don't know, maybe the purple will show up nice. And we have this one here. We have these two right triangles that make up this bigger triangle. So what we might be asking ourselves is, well, this is like the generalized Pythagorean theorem, the law of cosines. So maybe what we might try and do here is think about the Pythagorean theorem on each of these triangles. Let's do it on the blue one first and see if we get any nice information about it. What I would like to do here is just note that this entire length here is C. Okay, so let's see if we can do the Pythagorean theorem on this blue piece and see if it gives us out any nice information here. Okay, let's first try to think about what this height here would be. What would be the height here? Well, since we have the Pythagorean theorem, and let's say we would know this angle A here, so I'm just going to write A here. Well, let's think about what the sine of A would be. The sine of angle A, remember sine, if you want to write it up here. So, some old hippie, another hippie, tripping on acid. We got SOHCAHTOA up here. So sine is opposite over hypotenuse, so sine is the same as h over b. Okay? So we can solve for h. So notice here that h, if I multiply both sides by b, h is the same thing as the b times the sine of b. Interesting. So, and similarly, let's think about what the cosine of a would be here. What would be the cosine of a? Well, cosine is would be adjacent over hypotenuse. So let's give this a name from here to here. Let's just call it, I don't know, how about we call this length here, we'll call it L for right now. And I'm not sure what it is, but we'll call it L. Okay. So this means that cosine of A would be adjacent over hypotenuse. This would be L over B. Or we could solve for what L would be here. We should note that L here is equal to B times the cosine of A. So it's nice here that I can write this height right here just in terms of the A, B's, and C's. I could find this length L here just in terms of the A, B's, and C's. So if I erase some of this picture here, we've made a nice discovery. This length here, L, the length from here to here, well, what we know is this is the same thing as B times the cosine of angle A. That's nice. This isn't an L anymore. It has B's, it has angles A in it, so this is nice. And similarly, we know we know that this height right here we just discovered was the same thing as b times the sine of a. This is b, this would be b times the sine of angle A. Cool. All right, so let's erase what we have here and see, did we get anything useful out of this nice right triangle here? Okay, so I'm just going to draw it in a smaller version, this blue triangle. I don't know, maybe I'll just put it over here. So again, we're just playing around. We're just playing around. This is fun. This is fun. Okay, so we know this is B. Okay, we know that this length here is B times the cosine of A. We know that this height here is the B times the sine of A. So now we have a right triangle, and we're saying, hey, I know the lengths of the legs. I got the length of the hypotenuse. This is all in terms of B's and A's. Pythagorean theorem. Let's see if it does anything nice for us. What does the Pythagorean theorem say about this blue right triangle? Well, it says that the square of the hypotenuse, this is saying that b squared is equal to the sum of the square of the legs. So how about a b times the cosine of a squared plus a b times the sine of a quantity squared. So this is what the Pythagorean theorem says. Let's kind of, for good notes, kind of block off what we're doing here. We're looking at this right triangle, and we applied the Pythagorean theorem to it. Well, does this tell us anything interesting? I don't know. Let's see. B squared. Okay, so this is b times cosine of a. So I'm going to write here, this is b times the cosine of a. But when I'm squaring that, I'm basically multiplying this by itself twice. So b times the cosine of a. I'm showing a lot of gory detail right here. Order of multiplication doesn't matter, so this is b times b. That would be b squared times, I get a cosine of a times another cosine of a. So I have cosine of a quantity squared. I'm really showing this because a lot of students really struggle with this notation. When I take a trig function and I square it, it's very common we don't put the square here. It's common we put the square here. So this means b squared times the cosine squared of a. So when the square is here, what does this mean? It just says I'm taking cosine and I'm multiplying it by itself twice. So this is b squared times the cosine squared of a plus, I'll go ahead and erase this here. Okay, plus we would get another b squared times the sine squared of a. Cool. Okay, so let's look at this a little bit further, see if we can kind of clean this up. Well, notice on the right-hand side, at least I have a common factor of b squared that we could factor out. So b squared would be equal to b squared times the cosine squared of a plus the sine squared of a. And now you might be thinking, sine squared plus cosine squared, or cosine squared plus sine squared. This is just one. This is just one. This is like the most famous trig identity, that sine squared plus cosine squared is 1. So this tells us that b squared equals b squared times 1, or just that b squared is equal to b squared? This is kind of like a, it's like, I don't know, it's my best thinking face. How do you do a thinking face? I don't know, is that like a thinking face? I don't know, I'm trying. Okay, so this isn't, unfortunately, this is sad news. Because this didn't tell us any new information. This is like, what are you doing to us here? This is nothing new. This is we didn't discover anything new about thinking about the Pythagorean theorem on this blue triangle. Womp womp. What about the purple one though? Don't give up hope. Don't give up hope. You want to note here? No new info. No new info. This is just basically saying, square root both sides. That's just basically saying that b equals b. B is the same as b. I already knew that. We want more information. This was not helpful for us to think about the Pythagorean theorem on this blue right triangle. So let's do it on the purple one. Well, what does the purple one have to say here? Okay. Well, let's think about it. And I don't want to give up on this b cosine of a, this b sine of a. What we could do instead is let's think about this purple triangle. purple triangle. Okay. Yeah, I know this would be A. Okay. Well, I would know the height, or I would know the height, or I guess if we're standing here, this would be the opposite side. Well, that would be the same thing as B times the sine of A. Notice here this is still going to be the B sine of A. Still the same height here. Okay. Well, what would this length here be? Well, notice we called this length here L a second ago. So if this entire length here is C, if I take the entire length C and I remove this blue piece, I'm just left with this little purple piece. So this should be the same thing as taking this entire hunk, subtracting off the blue, subtracting off this L piece, and this should be the length of this purple. Now what is L? L is the same thing as B, cosine of A. So this length right here must be C minus B times the cosine of A. I don't know, maybe we're going to get something cool out of this. Okay, so for this purple triangle, this length here, which would be the adjacent side, this is C minus B times the cosine of A. Okay, interesting. Okay. Well, let's see what we can do here. Now I can apply the Pythagorean theorem to this right triangle, and let's see what we get. So what does this say? The Pythagorean theorem would say that A squared is going to be equal to, okay, the sum of the square of the legs. So it doesn't matter which one you do first. Let's do this one. So let's write a B times the sine of A. I'm going to take this quantity and I'm going to square it. And then I have to add, parentheses, a C minus B times the cosine of angle A, that quantity squared. So again, I'm just doing the Pythagorean theorem. What happened to my black mark? We're just doing the Pythagorean theorem. Okay, let's see if this leads us anywhere nice. Okay. So again, we're just exploring. Maybe we'll get something cool out of it. A squared would be equal to, well, this will be the same thing as B squared times sine squared of A when I distribute in the square. Okay, over here we got to be a little bit more careful because when I'm squaring this sum, or I guess it's a difference, I have to FOIL it out. So let's take some time to FOIL this piece out. No, maybe I'll do it right here. So we have to do a C minus a B times the cosine of A, and I got to multiply that by itself. I get another C minus AB cosine of A. Okay, so let's go ahead and multiply this out. So I'll get a C times a C, so we've got to FOIL this. C times C is a C squared. So we'll get a C squared. We'll also get a C times a negative B cosine of A. So we'll get a negative, how about we write a BC times the cosine of A. That came from me multiplying the C times the negative B cosine of A. I just kind of redid a little bit of order of multiplication. Minus, I'm going to get this term times this term, so I'll get another negative BC times the cosine of A. Maybe what I'll do here is I'll make this cosine here a little bit larger. Okay. So this times this. Now I'm going to get a negative B cosine of A times another negative B cosine of A. That's going to be a positive B squared times the cosine squared of A. I apologize. I'm so stuck in the corner over here. Hopefully you can see that. So I'll write it over here. What do we have? This is all a C squared. Well, we have two of these. So minus a 2BC cosine of A plus, when we multiply, I guess this would be the L in FOIL, we got plus, because there's two negatives, a B squared times the cosine of A squared. Okay, so we FOILed it out. Let's see what we get. So let's put that right here. Plus we get a C squared minus a 2BC times the cosine of A. Okay, I'm going to erase a little bit of this so we have a little bit more room. Okay, plus a B squared cosine squared of A. Cool. So So where does this lead us? Where does this lead us? What can we do here? What can we do here? Oh, I don't know if you can smell it, but I can smell it. I smell a 1. I smell a sine squared plus cosine squared. Look at these two pieces here. Look at these two pieces. Let's group those together. Let's group those together. So this is the same thing as an a squared. Well, that's going to be equal to, well, if I put these pieces together, let's just put them next to one another. And also notice that these two pieces together have a common factor of b squared that we can factor out. So moving these over here, this is a b squared. Now in parentheses, I'll have a sine squared of a plus cosine squared of a. That smells like a 1. That smells like a 1. But let's tag on the other pieces. I put these two pieces together. I factored out the b squared. I still got this extra plus c squared minus a 2bc cosine of a. Oh, this is starting to look familiar. This smells a whole lot like 1. So after all this, we have that a squared is equal to b squared plus c squared, Pythagorean theorem, minus the extra piece, 2bc times the cosine of a. And there we have it. There we have it. We got some fruitful information out of this purple right triangle. And all we did was we just did a little bit of SOHCAHTOA, a little bit of Pythagorean theorem, a little bit of foiling, and bam, we got the law of cosine. So here it is. So this is one version of it. Okay, how could you get the other versions? You could get the other versions really just by, rotating the triangle and doing the same exercise. But this is the law of cosines. Beautiful. How fun is this? Just sitting back, using the tools that we have in math, and just exploring. And look what we got. The generalized Pythagorean theorem, the law of cosines. I hope you enjoyed this video. We'll see you in the next one. Take care.